All right, dude, we are live. What's up, guys? This is Dem Keys, and today I think we're just gonna do some Git reading. Between yesterday and today, I actually give me a second. I just need to open up something and uh, just a second. Okay, yeah, sorry about that. I horrible time for me to get distracted right in the middle of my intro. But between yesterday and today's stream, I have been busy working on the content pipeline. More specifically, I was looking into the logic for detecting silence within a certain segment of a video using FFmpeg, and more specifically the filter system in FFmpeg, because there are different types of filters that you can set up. And sorry, zoned out. There are different types of filters that you can set up, and one of them is the silence detect filter. Now, I um, as I was discussing this with Gemini, at some point we came to the conclusion that, oh yeah, I was trying to remember exactly where at what point that was, and I believe this was on stream yesterday that I discovered this. So within FFmpeg we would be using a certain filter, right? We could use the filter, and that's supposedly going to give us a certain type of output, but I wanted the output to be in JSON. So I asked Gemini that, hey, is there any way that I can get this in JSON? And Gemini said that FFmpeg itself doesn't do that. However, you could use another tool called FFprobe, which comes bundled with FFmpeg, and through that you can get the data that you're looking for. We're just going to have to format the entire command in a different way. We would still be using filters, but in a different way. And after a bunch of trial and error, because I had to, so Gemini gave me one of the FFmpeg commands. I can actually show it here. Hold on, because that's what I've been working on up until this stream. That's what I've been working on. It was actually, I have the code here, and as you can see over here, there's a bunch of errors. This was all the trial and error that I was doing. These are the various iterations of the command that Gemini gave me. The first version that Gemini gave it, there was some error popping up. I pasted the entire error along with the command to Gemini, and then Gemini said that, oh yeah, that's my bad. So and so thing is old, or so and so thing needs to change, or this might be the reason why this error is showing up, or whatever. The great thing is, and this kind of gave me an idea of why agentic workflows are so successful, because I believe they are able to do their own trial and error, however slow it might be. I mean, it'll depend on your hardware, how slow it's going to be. Give me a second. Yeah, it'll depend on your hardware, how fast or slow it's going to be. But it's still great, because this trial and error that I was constantly doing, this thing, I believe this would be done much, much quicker through an agentic workflow. Because for me, it was like, okay, I spoke to Gemini, I said, I need so and so thing, um, I need to do so and so thing. And then Gemini gave the FFmpeg command for that. And then I was like, okay, this is great. And to be fair, I hadn't tried that out, what Gemini gave. The FFmpeg command that Gemini gave, I hadn't tried it out yet. Um, but I wanted to check with Gemini whether I would be able to get the output in JSON format, because it wasn't coming in a very serialized format. And so I would have to, write my own parser, or at the very least use regex to do the thing, to parse the entire output and get some useful information out of it. I didn't want to do that because it's very error prone. So I wanted to see if there's a way I can get this in JSON, because there's JSON parsers in pretty much every language. It's a standard serialization format. So at that point, Gemini said that, okay, so this is what I'm talking about here. What I'm trying to show you is the whole um, that whole process of back and forth between me and the LLM, and like just compare this to what it would be like with an agentic workflow where the agent, I'm assuming the agent is going to talk to another agent, which is going to be, you know, uh, the LLM to give the the response, and then this first agent is going to try that out, see if it works out, and then hand the hand the result back, and so on. I should actually I should actually learn a lot more about. I had that planned. I actually do have that as part of my list of courses to go into, but holy shit, dude. We've branched out so much that at this point I'm struggling to get back to the ESP32 stuff. I don't even remember how I branched out from the ESP32 stuff. I remember I was uh, doing research on Git related stuff, and I knew that I had some missing pieces of knowledge that I needed to gain. I had some missing pieces that I had to fill in, basically. Sorry, zoned out. I had some filling pieces of knowledge that I had to. Did I say filling pieces? I had some missing pieces of knowledge that I had to fill in, and I think that's how I branched out. Because the last thing we were doing is looking into PWM stuff in ESP32, and uh, then a bunch of things happened, and I just don't remember. I need to go look at the VODs and see at what point, because I remember when we branched out, the very next stream that I had done, it mentioned the branching. I didn't really call it branching explicitly, but the very next stream that I did, we did actually branch out. Give me a second. Okay, yeah, the very next stream we did end up branching out, and since then there's been a bunch of other branching out that has happened. Like, holy shit, dude, I branched out a lot. I branched out a lot. Holy shit, dude. Anyways, so well, back to this thing. So, Gemini gave me the ffprobe command, because ffprobe can actually output the thing in JSON, and hold on. Yeah, you can see here the very last command, the very last, what do you call it? The very last words, the very last flag. The very last flag that we pass here is print format. Print format JSON. So this tells ffprobe that we want the output to be printed in JSON format. And then there's a bunch of other extra stuff in here as well that I had to basically I had to refine this command over a couple of iterations because at first there were a bunch of errors popping up. One set of errors would pop up, then I would go to Gemini. I would say, okay, this is the error that popped up for this command with so and so flags, and then Gemini would analyze that and explain what happened, and then give me a solution for that. I would try that solution. A bunch of other errors would pop up. I would go back to Gemini. Hey, so and so errors popped up, and then I would try the next solution Gemini gave, and I kept doing this. I did this a couple of times until the errors stopped, and then I actually got the result. So the command ran successfully, and I got the result. And then I looked at the result, and the JSON file was just massive. Then I went back to Gemini, and I said that okay, there's a whole bunch of basically what I got was like so there was let's say one dictionary. Within that, there was one key called frames. That frames key's value was an array of dictionaries. And there, like this file had like 40,000 lines. Like literally it had more than 40,000 lines. And it was a bunch of empty dictionaries. I don't know if somewhere in between there might have been some information, but I explained this to Gemini, and then Gemini said, okay, yeah, looking at your command, this is the reason. And then it mentioned that apparently the command is going to output data for, I think it was saying every frame or every something. And that's why if there's nothing to report for a specific frame, it's just not going to give you anything. Now, what we are reporting here, quote unquote reporting, is the beginning of silence and the end of silence. So that's the filter that we've set up here. I don't know if it's still called a filter, like when we are using it in ffprobe. I need to go back to Gemini and ask it to explain the entire command to me so I can write it down as like one big detailed comment within the Python code where I'm going to be invoking this. But yeah, Gemini explained that it's giving a bunch of it's giving information for every frame or something like that. I think it was talking about every audio frame, which I didn't fully understand, but I didn't dig too deep into it because I had to make progress with this. And Gemini gave a solution for that as well. The solution was, I believe, this thing, read intervals. I haven't looked into how this does the thing. This and here, metadata or a metadata mode, print something something. Hold on. Yeah, metadata mode print. I believe this was also this was part of the solution. And after this, sorry, no, hold on. This wasn't the solution. This was the way to get data. After doing this, I did get data because in the previous thing I had an error. I didn't have an error. Sorry, I had an issue where the output. I was getting JSON output, but there was a bunch of empty dictionaries in the output, and there was like 40,000 plus lines. Give me a second. There was like 40,000 plus lines in that file. I wasn't sure if there's any data in the file at all other than those empty dictionaries. And then this thing that I was showing just now, read intervals and a metadata and stuff like that. That was Gemini's solution um, to actually give me the useful data. However, even after getting the useful data, there was still a bunch of empty data in there, a bunch of like empty dictionaries. I think I might be getting some bits of information wrong. I can't remember how I got from just like a blank JSON file or well, blank with structures still, but like a blank JSON file, how I got from there to actually getting data in there and still having blank data. Sorry, zoned out. Anyways, so in the end, sorry, I'm just not able to remember a bunch of the information, but at the end of it, I can show what I got. Um, Indexed clean. So this is the data that I this is not the data. Where's that? Did I close the thing? Silence data. So this is the file that I got. This is the file that I got. I'm also just noticing a breadcrumb kind of thing. I'm not sure if I'm getting that right. Um, did I miss some data here? Maybe some data popped up. There is data in this. There is data in this. It's just that I have to scroll a little bit. You can see at the top here, this is a dictionary. There's a key called frames, and within that, there's basic frames is basically an array of dictionaries. Now I can scroll there. This is so it says here silence start, and then the silence goes on up until this point, silence ends. So this is saying what 59.5 seconds, and the silence started at 58.8 seconds. Um, I set like a silence duration of 0.5 seconds. So if there's anything more than 0.5 seconds, it'll log that as silence. So this is one section, and then there's probably going to be a couple more. And this is the let me close this. This is the silence data basically. Give me hold on. Where did I put the file, dude? Okay, all right, sure. So Gemini gave me. Give me a second. I just realized that I forgot to refresh this feed after starting the stream. So Gemini gave me a little 3-line kind of thing that helps me. Not even a 3-line kind of thing. It was just reading the JSON data and then using list comprehension to get um, basically any dictionary that has the key silence something. No, that has the key tags. Yeah, that was it. So it would just get the dictionaries that had the key tags, and hold on. This is what we end up with. This is the result. We pretty much filter out all of the data to get only the dictionaries um, that have the key tags, and then within that we're going to read if there's silence start or silence end or whatever, and this is how we are going to kind of calculate where our silent segments are going to be. So this pretty much gives us our timestamps for sections where silence is there, and we can then use this. We would then be crafting a new ffmpeg command in which we're going to feed all of these timestamps. We're going to craft like a um, we're going to craft something in Python, so it's going to be dynamic, and depending on how many dictionaries there are, it's gonna expand or shrink accordingly. So I don't have to enter these these time values manually. It'll all be done dynamically via the script. Once we have this data, we can then craft that ffmpeg command and feed into it the sections that we want to skip, we want to slice out. And I'm going to be using the re-encoding process, not the slicing process, or the copying process, I think it's called. The copying process is basically like it doesn't re-encode anything. It just goes to that section in the frame and reads. It goes to that section in the list of frames, and or sorry, not in the list of frames. It goes to that time period and then reads the closest frame that it can find. And this is like keeping in mind that there's an encoding mechanism that has encoded this data, and so the data that it stops at may not necessarily uh, be a frame. And as a result of that, you could end up in situations where the beginning or the end of this clip that you have sliced out using this lazy process, the beginning or the end of it could either have a couple frames of blank screens or frozen frames or some other issue. But it's a tiny bit of an issue to deal with, which you may or may not have it. It's not always going to be there, but like it can happen, right? I don't want to do that when I've got so many sections that I've got jump cuts in. This isn't even like a beginning and ending um of the video. It's like sections in between the video are being sliced out. So I would much rather use a proper re-encoding process, proper re-encoding workflow. And that's why I'm just going to let ffmpeg do the entire thing. I'm just going to supply it with all the start and end timestamps, and it's going to pull out whatever data it needs and then re-encode that entire video, so everything, all the data is properly formatted, properly encoded, and whatever other proper mechanisms need to happen, all of that will be done. But yeah, so far this is what I've been working on. I'm currently working on how do I say this? So that command that I showed you guys, this command, I'm currently working on the Python version of this. Pretty much hold on, I'm using subprocess.run to run this entire command. I need to do some research with Gemini about the difference, because there is apparently a massive difference between running the command like this versus running the command in the shell. Apparently this doesn't even involve a shell, so that's why I'm interested in finding out like what's going on here exactly. Um, but yeah, you can see over here. By the way, I learned this new thing, um, and it's crazy that like I mean it's not crazy. This is the perfect example of what I like to say, that you might you might have years of experience in a language, in a programming language, but there's still going to be stuff for you to learn. Like today, I learned that Python has this thing where you can, if you have a really long string and you know the string is going to be divided up into multiple, you know that the string is going to be so long that you need to divide it up into multiple sections, then you can do it in this way. This is apparently called, hold on, give me a second. Yeah, apparently this is called implicit string literal concatenation. So what ends up happening here is I supply, this is not exactly a tuple, because there's no commas at the end of each literal, but we are enclosing this within parentheses, though they're not meant to be like separate items. You are able to specify each of these as separate items. So like if you need to send it to the next line and next line and next line, Don't bother doing it if it's a small enough line, because at least in my case, because I have a formatter that's actively working, it's most likely gonna just squash the entire thing. Like if I do this, let's say str01 equals this, and then I'll do ABC, and then DEF, and then GHI. So you can see these are clearly very small strings, right? As soon as I save this, the formatter just squashes the entire thing, and we have our string there. It doesn't do that with this string because this string is pretty long, together with this string, which is also long. So when these two would be concatenated, then the string would become way too long, and the formatter has a certain threshold for, past which point it'll actually split up the string into, or the thing into multiple lines. So it probably applies the same logic here, um, which is great. I actually didn't know this about Python, and I've been doing Python for more than a decade at this point. So this is definitely good to know. Okay, now, um, when it comes to Git, we're gonna switch topics now. When it comes to Git, I've been using Git now for, a little bit, more regularly, I should say. Like in the past, I've used it on and off, but like more regularly, I've started using it in the past couple of months, much more regularly. And in the past, let's say month, I've been doing it way more regularly, to the point that I decided to learn about remotes and how to maintain a central repo, how to maintain two central repos, and stuff like that, right? The two last things that I wanted to look into, in Git studies, or in the Git workflow, I'm not sure what to say there. The two last things I wanted to look into are branches and tags. Now, branching is an interesting concept. I know the basics of branching, but like local branching, not not when branching involves remotes. I know a lot about like very basic local branching. I know a little bit about merging branches together. There's still some stuff for me to explore there, some details for me to um, finalize, for me to clear up. Give me a second. I forgot to open my stream on my phone. More specifically, I forgot to open my chat on my phone. Okay. Right. Actually, give me another second. Okay. So, I know the basics of branching. I know how to create a branch, switch to the branch. I know, fortunately, now I know how branches work even on a lower level. I know how Git tells us that, hey, so and so branch is. I can actually show it here now, and I'm super happy about that. I'm incredibly happy about that. The fact that I took the time to learn. I don't know if I've made commits here, so I don't know if this is the best. Where have I made commits? What's a more recent project? I believe it was the dumb programs. Hold on. Rust. What did I even call it? Yeah, Rust dumb programs. So here I can show you. Actually, I didn't need to show you this in. Yeah, I didn't need to do this. I because I was just planning on showing you. I was just planning on showing like what the branching thing looks like. Um, so hold on. So it says here. So this is how we know what head is currently pointing to, and the next commit that you make is going to be made to this branch. This tells us which branch is currently checked out, and if we trace that and go there, the main branch is our current branch. That's actually the only branch that we have, but that's our currently checked out branch, and you can see that main. I guess you can say the tip of main is this commit. So that's our latest commit. Once we have more branches, then we're going to have more information shown here. And I'm glad that I took the time to, you know, learn that kind of stuff, because that'll definitely help me with exploring things and experimenting once we start doing more branching stuff. And how do I even say this? I'm not sure how to say this. Basically, we'll be able to experiment more. We'll be able to analyze things much more. Once we start doing the branching thing, we'll be able to analyze it more because like now I know about how these things work on a lower level. So now we actually need to learn on a higher level how branching itself works. Branching, merging branches, remote branches. Hopefully this section will also cover remote tracking branches. Right. So, um, I guess, so after today's stream, which unfortunately even today's stream, I started late, so it's not going to be a very long stream, but it is what it is. I had some stuff going on because of which couldn't get to it. Um, I also didn't upload the vlog that I recorded yesterday. I should upload that today. Yeah, I'll try to remember to upload it. I also need to upload. I need to resume uploading VODs to the VODs channel. Um, but yeah, yeah. So I guess let's get into this. Let's read this. I'm gonna go into the basics, and then I definitely want to explore merging, how merging works, what exactly is happening during a merge, what other topics do they cover in branching. So we have basic branching and merging. We have branch management, branching workflows, remote branches. That is something I definitely want to look into because usually when we pull or push, so when we fetch, um, we are fetching the branch. When we just do a regular fetch, I think it pulls all the branches that are not up to date, or all the branches that are currently, I'm not even sure how to say this. It pulls any new branches that might not exist. Actually, you know what? We'll find out here what happens when, like exactly what happens when we, you know, do a fetch. It'll most likely mention it here. I still do git fetch, git merge, and git push manually, like through the CLI. All of the other stuff, staging, committing, switching to branches, and various other things. I do all of that stuff through Git UI because it's just so much more convenient. Not having to enter, you know, big commands for every single thing. I mean, to be fair, not all of them are like big commands, but I would much rather prefer to be working with a TUI for, you know, multiple different operations rather than having to remember how to do every single one of those operations through a specific Git subcommand, and then also having to remember its arguments, its parameters. That's not the most convenient thing. I prefer TUI. But yeah, I want to look into the remote thing as well. Also, rebasing. I've never explored this. I have no idea what this is all about. So I wanna explore this as well. I think past that point, we will be ready to get back to. I don't remember what all I had going on. Uh, let's take a look at the list here. Um, Impl Rust for ESP32. Yep, we've got that. Understanding West term. Yep, we've. I just realized this. I have this in two different places. Content pipeline, definitely still working on that. Um, Wait, is this my list that I'm supposed to be words? Holy shit, supposed to be working with? Is this my list? Um, oh, KB tool. Yeah, I'm still working on KB tool. I was actually I did make some progress with KB tool. I got a bit distracted with another feature that I'd seen. I found out that apparently there is an autocomplete feature in Inquire. Inquire is a crate, a Rust crate that allows you to give the user prompts while the program is running. So it gives you a bunch of advanced features like input validation and um, this autocomplete feature and a bunch of other stuff as well. I'm just not able to think of it and list it out, but there is a bunch of other stuff that is already just implemented for you. At the very least, you would need to define a struct that implements a certain trait, or you might need to define a closure that defines some functionality that you want within a certain thing. Like for validators, you're expected to pass in a certain type of closure with a certain type of signature. So at the very least, you'll have to do that, but you don't have to handle um, a bunch of the a bunch of this logic that has been implemented for you. You don't have to do it from scratch. You don't have to do it manually, which is a huge it's a huge plus point when you're making these kinds of CLI applications where you give the user prompts to do stuff. Oh, another good example is the date selector. Like there's a proper date selector TUI widget that pops up when you invoke the date selector thing, and it lets you select the date. It lets you format the date. Well, the API lets you format the date. The widget itself just lets you select the date. You can format the date to whatever format you want. They have they have a dedicated format function for that. There's a bunch of extra functionality that you can add to these things as well. It's great. This crate is it's something that I didn't realize I needed until I actually explored it, because when it comes to CLI applications, my mind would be like, okay, CLI means I would have to give all of the information before invoking the command, before calling the command, as in pass all of them as flags with the command, and then the command is going to do something. I would very rarely think about actually giving the user prompts, mostly because of how hectic it can be. It's a little more complicated than just doing a simple, print line, hey, user enter so and so thing, and then doing a read line expecting the user to give input. That's fine, but if you don't have a structured way of doing it, you'll run into issues. If it's a very simple thing that you're trying to do, I've done that, like with my Rust dumb program. The very first exercise in that was the um, terminal virtual pet, which it asks for input. You give it input, and then that input is going to be parsed, and something will happen based on that. right? That's a very simple use case. But when you have more advanced use cases, when you're trying to create a CLI, um, which in which you want to have very strong input validation, you want to have let's say specific types of functionality. You want to have specific things that happen when the user enters details. Things get a little bit complicated if you have to implement everything from scratch, um, just to be able to do prompts. Like you're having to reinvent the wheel for nothing. I mean, it'll be a good learning experience, but you're not going to get jack shit done. You're not going to make any progress with your project because now you're you have a new project which is creating this whole, user prompts system when you could have just used a crate that already implements that functionality. So yeah, I forgot how I got on this tangent about Inquire. um we were talking about Git, right? I have learned about, like, merging branches. I've learned about fetching. I know that we fetch branches. We even push branches. When it comes to pushing, we're usually pushing a branch. We're not pushing just commits. But when you push the branch, then everything that's in that branch is also going to get pushed. So whatever is not on the other end, that's all going to get pushed from here. Basically all the Git objects that belong to that branch, all of them are going to get pushed along with the branch. And if the branch doesn't exist there, it'll be created there. And in that case, literally the entire branch is being pushed. But if the branch already exists, then I'm guessing it just pushes the data that doesn't currently exist. Um, So what I wanted to learn, because at some point you would then also be merging. So like if you've pulled data from a remote, you've pulled the branch, you would then want to merge that branch with your current branch. I mean, depending on what you're trying to do, what your, workflow is, but at some point you would be merging the branch, even when it comes to remotes, even if you're not explicitly using the branching feature, like creating new branches and doing some work and then merging it into main. Even if you're not doing that, if you're just, doing fetch, after fetch, you're going to have to merge. If you're doing push, push is, I don't think push is merging. Push is not, it's not part of this. Push pushes everything there. Um, I should look into what it looks like, because so far what I'm talking about is pushing to a Bear repo. One is a local Bear repo and the other is a Bear repo that's on GitHub. I'm assuming that is also a Bear repo, because at least from what I remember with the conversation that I had with Gemini, or in the conversation that I had with Gemini a while back about how things are working on the GitHub side, Um, of course, it's fairly sophisticated, but in the back end, apparently, it's still using like this very basic functionality. Um, Again, it's highly sophisticated, but like what's happening in the back end is somewhat similar to what we would be doing here. We are not directly working on a bare repo. We have a working copy when we are doing stuff through the web UI. There's a working copy, and whatever we push, it then gets pushed to the bare repo. I'll have to explore that conversation again. I can't remember all the details surrounding it, but there was something similar to that. We aren't like working directly on the bare repo. The bare repo is somewhere. We have like a working copy. And so when we push from our local machine as well to GitHub, it gets pushed directly to the Bear repo. And I was having a convo with Gemini about the merging thing, the pushing thing, whether it merges or not. And after Gemini explained this, I was like, okay, let me see if I understand this correctly. It's not actually merging. All it's doing is pushing all of the stuff that doesn't currently exist, because Git turns everything into a Git object, right? Your blobs, your trees, your of course your commits, your tags, all of that. It's a Git object. So you have the Git object, Git objects. You have the branches, and w- based on the branch that you're pushing, it's going to push the appropriate Git objects, and then just increment the pointer for that specific branch to match the latest commit, because commit objects are also being pushed on there. Give me a second. Okay. All right. Um, yeah, you know what? I think we'll continue with this now, because we've branched out a lot. I really want to get back to the stuff that we were doing. And yeah. Um, I need to somehow get back to ESP32. There's this backlog of stuff. I still need to continue learning Rust. There's a bunch of things that I don't currently know, and or there are things that I've explored in the past but didn't really go too deep into them. There's definitely a bunch of things that I don't know, like a lot, a lot of things that I don't know. Fortunately, I mean, I'm happy to say that I'm no longer at like the beginner part of Rust. A lot of the stuff that I'm trying to learn is higher, more advanced stuff. I don't know if I would call iterators advanced stuff, to be fair. Something like multi-threading, I would say, yeah, more advanced stuff. Stuff like async, I would say that's more advanced stuff. Iterators, I don't know if I would call that advanced. Um, but yeah, I mean, I know how to work with iterators to a certain extent. I guess this falls under one of those things where like I've explored this a tiny bit. I haven't really gone too deep into it, and I would like to do that. Smart pointers, I would count that as advanced stuff, even though they do teach you that in the like basics, like at the beginning, they teach you about smart pointers. I think they go into much more detail later on in the book, not like at the very beginning. Zaynar, hello, hello. How's it going? How's it going? Unfortunately, you caught me right at the end of the stream. I'm doing okay. I've been a bit busy today. It's been a bit hectic, and I finally managed to like start up the stream, even if it was late. Um, I was only able to stream for like 45 minutes, but it is what it is. I hope you're doing well. I hope things are going well with you, and the stuff that you were doing research on. You were working with, I think, agentic, something to do with agents. You were working with I don't remember, or something to do with just LLMs, or something like. I hope that's going well. I hope that's going well. Unfortunately, we are ending the stream right now. I'll stream again tomorrow, hopefully, um, if nothing comes up, and hopefully I'm able to start the stream earlier tomorrow so I can stream for much later. Um, well, glad to see you. Keep it up. You too. You too. And thanks for stopping by and saying hello. Um, but yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.